1050 centimeter cube of helium gas was produced at minus 33 degrees Celsius and 700 millimeter mercury. What volume would the gas occupy at 23 degrees Celsius and 750 millimeter mercury? Solution. Before we proceed, if you are yet to subscribe, kindly do that, and as well click on the notification bell so you don't miss out on more videos like this. Let's continue. Looking at the question above, we are given the volume of the gas, the temperature and the pressure as well. Though for the final values, the volume of the gas is unknown. This is a question on gas law where we have the volume, the temperature and the pressure as well. We'll be applying the combined gas law. Now from the combined gas law, we have the combined gas equation P1V1 over T1 equals P2V2 over T2. So I'll be writing out the formula out now. We've written out the formula we'll be using. That is the equation derived from the combined gas law. Now the next thing to do is to write out the values. From the equation written above, the subscript of 1 and 2 here refers to the initial and the final values respectively, while the variables of P, V and T represents the pressure, the volume and the temperature of the gas. Now let's write out the values we're given from the question. For the initial values, for the pressure now, P1, we have that to be 700 millimeter mercury. Then V1, the initial volume of the gas, initial volume of helium gas here is given to be 1050 centimeter cube. We have that written. Then for the temperature now, the initial temperature of the gas, which is T1, is given to be minus 33 degrees Celsius. And we'll be converting this to Kelvin. To convert to Kelvin, we'll be adding 273 to whatever value we have in degrees Celsius. So here now we have minus 33 in degrees Celsius. Then the 273 will be adding for the conversion. Plus 273, our unit Kelvin. So this gives 240, the unit in Kelvin as well. Now this for the initial values. Then for the final values now, P2, the final pressure of the gas is given to be 750 millimeter mercury. Then the final volume of the gas, V2, that is unknown, and that's the question. I read again. It says, what volume would the gas occupy at 23 degrees Celsius and 750 millimeter mercury? So the volume is unknown. Then for the temperature, T2, the final temperature of the gas is given to be 23 degrees Celsius. So this is equivalent to, converting it to Kelvin now, we have 23 plus 273, our unit as Kelvin. So this gives 296, our unit in Kelvin as well. Now V2 is the only unknown we have here, and this makes it very easier for us since we have just one unknown. So we'll be making the unknown the subject of the formula. Hence we have V2 to be equivalent to P1V1 times T2 divided by P2T1. That is P2 times T1. Substituting the values for V2, we have V2 to be equal to P1 700 millimeter mercury multiplied by V1, which is 1050 centimeter cube, the unit, multiplied by T2, which is 296 Kelvin, divided by P2 750 millimeter mercury multiplied by T1, which is 240 kelvins. Now calculating this, for the numerator, we have 217,560,000 divided by the denominator, we have 180,000, and our unit, since we are dealing with volume, we have the unit to be in centimeter cube. So this gives 1208.67 units centimeter cube. This serves as the final answer. Now we've just calculated the volume of the gas at 23 degrees Celsius and 750 millimeter mercury, and that's gotten to be 1208.67 centimeter cube. That will be all. Do not forget to subscribe and click on the notification bell so as to be notified as soon as new videos are being released. You can also drop your comments in the comment section below. Thank you.